Good afternoon, students. Today we will be discussing part 2 of Unicast routing. Yesterday we discussed what is Unicast routing, why we have to route in a network environment, and what are the procedures through which we have to go. Now, before discussing the routing protocols, we discussed in detail the algorithm on top of which these routing protocol work. So we discussed the different types of algorithms yesterday. Initially, we discussed distance vector routing algorithm, how it works. Then we discuss about link state algorithm. If you can recall the idea of digester algorithm and pseudocode about how this overall algorithm works. And then later on we discussed about path vector routing protocol. Today, on top of that, the protocols that were developed on the basis of these algorithms, we will be discussing one by one. At start, we will be discussing routing information protocol, which is based on distance vector routing. Then we will be discussing about open shortest path first, which is based on link state algorithm. So from the name, you can understand that it will be open source, the description will be open, the specification and description will be open for us to understand how this algorithm works. And you can also, for research purposes, the idea can be changed and you can modify it. Thirdly, we will be discussing border gateway protocol, which is based on path vector algorithm, and this is the only algorithm this is the only routing protocol that later on we will be discussing that it is being used in inter-domain routing for a purpose of inter-domain routing, or in other word, when routing is done between different autonomous systems. So before going in detail of the routing protocols, students, let's see the existing internet structure. Initially, when the protocols were designed and they were used for routing purposes, the structure was not that complicated. There used to be a single backbone, and all the peers, all the customers, or the customer networks used to be connected. But right now the situation is getting more complex. There are competition in different or private organization. They have their own backbone structure, so we will have more than one backbone structure. In fact, we will have multi backbone structures, so which will provide connection between different network providers, and at the same time between different customer networks. So this is, in this figure you can see how the scenario of networking or interconnection of networks is getting complicated day by day due to different private corporations there who are now part of the network. So from where this journey was started, from where the idea of sending a message in a proper shape, in such a way that it is not sent to all, or initially before routing the idea was to broadcast, to send to all the data to the to the neighbors. But later on it started that the researchers started that why we should waste energy, and then they come up with the idea of routing, following a particular route from source to destination. So first routing protocol in this regard was developed in the form of RIP, or routing information protocol. It was a part of Xerox network system, but It was the Berkeley software distribution version of Unix that helped make the use of RIP widespread. Still, it is in use, though the version is different for specifically for smaller autonomous system. RIP is still, but initially at that time the version 1, now version 2 RIP version 2 is still preferred in smaller autonomous system. Okay, if you can recall, yesterday we discussed about algorithms, routing algorithms, and we used to go for least cost. But today, when we will be specifically discussing routing protocols, and in RIP, we will be discussing hop count as a cast from source router to the destination. So in other words, we will be going for that route where the number of hops are less compared to the other route. So hop count will be considered in routing information protocol. Here in this figure you see that we have 4 networks that are connected with each other with the help of 3 routers: router 1, router 2, router 3. And so we can say if some node is in this network and want to communicate with this node, with the node in this network, so the total number of hops here you can count as 3. Similarly, from here to here, total hops count will be 2, while from this network to this network the hop count will be 1. Here you can see uh, uh, so obviously there may be more than one route, and while sending a data from one network to another network, that route will be chosen by using WIN. RFI, our routing information protocol, is working on top of that is a routing protocol, so packets will be forwarding accordingly. We will see the internals, the packet format, while following the RIP routing information protocol in a while. Here you see uh, the routing for a router, the thing which are the decision is taken based on the forwarding table or routing table. So routing table, when on top of if you install RIP, is a routing protocol. So there actually you will have 3 information in the forwarding table. The first one is destination network. The second one is which will be the next based on the cast. In this case, in routing information protocol, the cast is basically the number of hops, and so on the basis of that, you next router will be selected all the way to till the destination network. It can be any of the 4 networks that we discussed in a while. So in previous figure, if you can recall, there were 3 routers: router 1, router 2, router 3. Okay, let me show you again. This is router 1. So its forwarding table will have information about all the 4 networks, but next router from N1 to N2 will be initially R1. That use from for R1 routing table, like here, the information given will be for here. That for N3, the next for N1, then the number, the cost and hops will be 1, because N1 and N2 are directly connected with R1, but N3 are connected with R1 through R2, so number of hops will be 2, while N4 are the nodes stored inside N2. N4 are connected with R1 through R2. However, the number of hop count in that case will be 3. Similarly, for R2 and for R3, the forwarding table will be same. Just we can take one entry like N4, R2 or N4 are connected with R2 2 through R3 and the number of hops in between are 2. So same goes for a router 3. So now let's see basically what protocol we discuss, we need to know the message format of that particular protocol. We can see the RIP, routing information protocol message format. You see different fields from COM, we mean the command mean either that message is sent to gather information request, or it can be in response if that request is sent. So in reply, the neighbor node or the node in the other network, it will respond through the response by where the value will be 2. Similarly, as I said earlier, we use two version currently version 2 is in use. We are for version, and reserve is like not in use, used for specific purposes. Network address you already know, subnet mask, next hop address, and the important thing here is distance. By distance we mean number of hops to the destination. So it basically defines how that particular packet will route, or the packets from that particular host will be routed to the destination by considering this distance. The smaller the distance, or in other words, the smaller the cost, or in other words, the smaller are the number of hops, the prefer will be that particular route from source to destination. Here you see, let's take an example. We have an autonomous system where we have 6 networks from N1 to N6. In this autonomous system there are 4 routers that are connected with each other. So firstly, by using RIP as a routing protocol, what you see, this is the routing table of R1, where N1 and N2 are directly, N1, N2 and N3 are directly connected here. So the cost are, because there is only one hop, so the cost will be 1. Well, for R2 directly connected with these N3, N5 and N4, and the cost will be 1. Similarly, R3 is connected with 2 networks such as N4 and N6, and R4, our router 4 is connected with 2 networks directly, which are N5 and N6. Now when these neighbors, they updated, when the neighbor receive information from their respective neighbors, so the table entries will update it time to time. So now you see, the old forwarding table or routing table for R1 was this. Now once R2 seen by R1, so definitely R1 will update the entries through R2. It's seen there's these 2 entries. So to reaching N4 here, where is N4? N4 and N5, N4 and N5, any node from these networks in N2 can reach there, where the number of hops are, the total cost will be 2. 2 routers are involved in between. So here you can see 2 network N4 and N5, any communication can be established over there. The hop counts will be 2, or in other words, the cost will be 2, because there are 2 routers that R2 and R1 are involved in between. Similarly, R3 will be updated once R2 is seen by R3, and also R2 is seen by R4, so R4 will update its entry in the table. So that's how the table will be developed, and at the end you can see the final ones. By final mean all the network informations are updated in the routing table. As at the start we see in this autonomous system, we have 6 networks from N1 to N6, and they are all entries are available there in each and every routing or forwarding table. You can see here all entries are here, but the only difference is like cost. Okay, let me take an example. If you want to reach N6 from R1, say N1 and N2 or any node in this network want to communicate with any node in N6, so it has to go through three routers. So the minimum hop count is 3 or the cost is 3, so the it will go through, because this is the shortest part, we don't have any other part. So that is how a routing information protocol works. Now let's move on to the another routing protocol, which is called as open shortest path first. It is also an intra-domain routing, mean the routing will be performed inside the autonomous system, right? So, but the only difference between these two is it is based on link state, which means that link state database will be established, LSDB, and for that you need to have link state packets, and definitely different mechanism will be used how to update that link state database. So it is based on link state in contrast to rep, which was based on distance vector. So further the only difference between these two will be at and the rep we use hop count as a cost, while here the cost will be based on the weight of the link between of the edges will be sorry of the verses will be signed based on the throughput metrics, like quality of service metric, like round trip time, delay time, congestion, and so on, right? So definitely that will be the choice of administration to decide to use hop count is one of the parameter also. So it means it will not just restrict itself to just hop count, other parameters will also be considered. So definitely the cost can be different, depends, like if the quality is better between multiple, if for example there are more hops but the quality or the chances of packet delivery is higher compared to when there is direct communication, there is no hop, still the cost over there will be lower. So instead of normally if I ask this question, so majority of you will say, sir, direct communication, but if the cost is lower, even if there are multiple hops consider to the other direct communication, you will select that based on open shortest path first. You have to select that the multi-hop path. Here let's see, from R1 through R1 the total cost will be 12, say let's assume through R2 up to network 4 the total cost will be 7, and again that cost is based on parameters like throughput, round trip time, reliability, and so on. And for R3 it can be 4. Okay, so now the forwarding table will be almost similar. The only difference between the RIP and OSPF is the cost difference, and at the same time it will follow the Dijkstra algorithm. You see here the cost for reaching from any network connected with R1 to an N4, so the total cost will be 12, while reaching any other network through R4, R2, the cost will be will vary. Here you see if any node is a destination node in N1, so the packet will go through R1 from R2, the total cost will be 9, and so on. So these are three different routing tables for when OSPF is used as a routing protocol. So it can be used, OSPF, as we said, for smaller routing, for smaller autonomous system we use RIP, but OSPF can be used for a small as well as large autonomous system where the volume of traffic is quite high, where the number of routers are definitely depends on number of hosts. If it is quite congested area, so definitely an autonomous system will be divided into multiple areas. So when it is divided into, so the routing will become more complex. In that case, to properly communicate between different areas, so there will be a leader area which will be designated as a backbone area in the whole autonomous system, whose responsibility will be to glue, to connect different areas together. So there every router will have different responsibilities. So how these responsibility will be recognized, for that we will be discussing different link state packets that are being communicated. Let's assume that we have an autonomous system here, which is further divided into three areas. So to connect these areas with each other, we will be needing a router which will be called as area guard router. And similarly, to connect this autonomous system with the rest with other autonomous system, we will be needing a router. So the mechanism along with the other routing mechanism will be different. There will be additional responsibility to not only pass on data among the different areas, network and different areas, but its responsibility will also be to connect with the other autonomous system. So definitely, uh, there the to update the link state database, OSPF requires that a router advertise the following to all neighbors for the formation of link state database. That the existing different entities as nodes, the different types of links that connects each node to what are different types. It can be network links, router links, summary links to the network, and at the same time different type of cost associated with each link depend on the cost as well. So in fact you will have 5 types of link state advertisement. Just like link state packet will be used for sending advertisement to the other nodes or to the other routers in the other areas, or maybe in other autonomous systems. So how they link state, but we will only restrict ourselves to a single autonomous system. So these advertisement will be required. Here you see different types, like this is, you can see point to point link between two routers. This is the network links that you see by a designated router is responsible to advertise the network links. Another type is LSP type is summary link to network, like you have two areas, so the router will be responsible, the area border router will be responsible to establish communication between two areas such as area 1, area 0. Similarly, there will be a router who will know all the links in that autonomous system, right? That is called as autonomous system router. Similarly, external links, like anything beyond the autonomous system, so the links that are required, because end of the day the job will be to pass on those packets in the links which are least cost. And OSPF, the least cost is based on, as we said earlier, on quality of service parameters like throughput, number of hops can be one of the parameter, packet delivery rate, etc. So if you go in detail of the message format of OSPF for these different types, for, as we said, 5 different types, so you will see the difference. This is the generalized OSPF header, so you can see that this is the common header for all the 5 types. This one, you can see the color scheme, that light blue, right? So you can see here, this is will be common for all the 5 header types. The only difference will be entries here. For neighbor IP address, the header is different from The second type to like information about routers, link information about network, similarly other networks. So you can see the difference. This is type 5. These information will be same as here, but which is the link state journal header, right? This is the link state journal header, and this is OSPF common header. So OSPF common header is same for all the 5 types. Let's move on to the final routing protocol in intra-domain routing. Basically, in inter-domain routing, up till now we discussed intra-domain routing mean routing between the autonomous system. So, what routing protocol is used for inter-domain mean between the autonomous system? So, the only protocol which is used in today internet for inter-domain routing is called as border gateway protocol, or BGP. So the current version is BGP version 4, and it is based on path vector algorithm, which we described yesterday, but it is tailored to provide information about the reachability of the network, whether in the internet that network is reachable or not. So here interesting thing is when we see the overall structure, assume that we have four autonomous systems that are connected with different routers. You see that autonomous system 1, 4 networks are basically in 1 and 2 and 3 and in 4 networks are connected with 4 routers. Similarly, autonomous system 2 is connected having one router which has 2 networks, and autonomous system 3 has 3 networks and 3 router, and same goes for autonomous system 4 where you have 1 router and 3 networks. Now the job, if you look between the autonomous system, right, autonomous system in, or we can say intra domain or intra autonomous system, you will be needing the same either RIP or OSPF, which will be installed on top of each router. But how to connect with other autonomous system? Here you see that this is router R1, which is not only responsible to communicate between different network and autonomous system, but it is also responsible to connect with autonomous system 2, right? So you have to install BGP or border gateway protocol. But there are 2 extended type of BGP. One is called as eBGP, or external border gateway protocol, or in another one is internal border gateway protocol. Here these routers can be used for internal communication as well, right? So I can ask the question from you that what router will be used as a external router. Here you see R1 in autonomous system 1, similarly R2 and R4, they are used as external router as well, because their job will be our external, or we can say border router. So their job will be to establish communication or routing with another autonomous system. So definitely eBGP will be installed on top of that along with iBGP. And what is iBGP? It is all other routes routers which are not border routers. For example, if we say an autonomous system, R3 is the that router where only iBGP will be installed along with the intra-domain. So we can say that a router which is border router, 3 things will be installed. Or 3 protocol will run on top of each other. The intra-domain, on top of that eBGP, and on top of that iBGP. While the simple routers in autonomous system, intra-domain will be working or will run on top of each other and iBGP. So now let's see one by one the operation of eBGP. Here, as I said, autonomous systems that 4 autonomous systems that are connected. through different routers, router 1, router 2, router 4, and router 6. So these, and similarly R5 and R9. So on top of that, eBGP will be running. So by running we mean it will maintain its routing table. And when we say path vector routing protocol over there, basically there are three entries. One will be the networks through which that packet has to go, are the networks that are connected in these autonomous systems, and uh, what is the next router which is responsible to connect it with that autonomous system that will be also there. So three entries: autonomous system, next, and networks will be there. So here for one, router 1, you can have these entries. For router 2, you have the next router. For router, sorry, for autonomous, this is R5. The autonomous system, it represent as autonomous system 2, and the networks that are connected here are N8 and N9. So that's how by running eBGP sessions you will have this routing table uh, for operating or for establishing communication or routing between different autonomous systems. So when we use combination of, once you install eBGP, so now if I ask which router, you have to install both. So the answer will be only the border router. So you clearly see the border routers here. This is border router 1, border router 2, border router 3, border router 4, and border router 5, and border router 6. So it means except R3 and R7 and R8, you have to install combination of both BGP and IBGP. So they will be running on top of intra-domain routing protocol. Okay, so once you install, so you will have two different combination of forwarding tables, and one for eBGP and one for IBGP. So that is how network is established. If we see the finalized BGP part table, the table entry for the different routers will look like this. For R1, this is for R5, part table for R5. Where is R5? Here you see R5. If to reach to net N15, which is N R9, it should go through R1, right? And there are three autonomous systems will be involved. That is autonomous system 1, autonomous system 2, autonomous system 1, and autonomous system 4. Similarly, if any node and network 8 want to communicate with N12, any node in N12, so it has to go through the R1, and the autonomous system again will be three autonomous system, that is autonomous system 2, autonomous system 1, and now autonomous system 3. So that is how that BGP part tables are updated. You can see for R9, R7, and R8. So here are the final forwarding tables that you can see. Now you can see the complete forwarding table for each and every router. Any network can be reached through, and it has all the information. If I say that N14, any node from N9 through all the way in another autonomous system, which is S4, its network in 14, any node in network 14, if they want to establish the connection, so it has to go through R1, and all the way it will reach the next router will be R1, right, for R5. This is R5. Okay, sorry, no R5. R5 is here, so it will go through R1. So this is the final routing table that is been. If you see R1, R2, R3, and R4, here you see information of every network, and same goes for the other routers. So if you see the format of path attributes, you will see different fields like O stand for optional bit, which is set F attribute is optional, P is partial bit, which is set F and optional attribute, and last and transit is last and transit, while T will be this is actually flags which will be raised, like which is called as T is called as transitive bit, which will be set F attributes and transitive, etc., etc. So now, how just like we see RIP in OSPF, so how the message of BGP will look like? What will be different field in the header of BGP? So there, because the types will be different, so for each type, the format will also be different. For example, for type 1, you clearly see that there is BGP identifier, but it is not there in type 2 and type 3. Similarly, you see other some of the fields are in type 1 but not in type 2 and type 3 and type 4. So these are different legends. They, again, you can see O is used for optional length, EC here, which is used in type 3, which means that it is used for error code. Every error has different code, depends on the type of error. Then there can be error subcode, right? So which is represented by ES here, and so on. Path attribute length, which is short for PA, uh, uh, which is used to attribute the path attribute length, what is the overall length of that particular path. So with this, students, I'm going to conclude today's lecture. We discussed in detail yesterday about unicast routing. Then we also discussed algorithms based on top of which different protocols are working. So we discussed 3 different types of algorithms, and we discussed 3 different types of protocols today, such as RAP, routing information protocol, which works on distance vector algorithm, OSPF, which works on length state algorithm, and a border gateway protocol, which works on path vector routing protocol. So we discuss, in fact, we discuss about inter-domain and intra-domain routing protocols. I hope now you are clear that how forwarding table or routing table are used to forward the data from source to destination. With this, I am concluding today's lecture. If you have any question, we will be discussing that in the Q&A session. Till then, goodbye.